Okay, go ahead.
Cool. So hello, everyone. My name is Ledesma. I used to be an undergraduate. I recently got my bachelor's in computer science, and I'm an incoming PhD student for biology at the University of North Carolina at Chapel Hill. So today, what I'll be teaching you guys is very much going through the basics of how to start with Unity, what you need to be aware of, and how to get started all the way until you can build and run something tangible on your device. And the particular focus of this is to get at least some VR or virtual reality running. So let's get started. I'm going to go ahead and share my screen really quickly. And this may be a little crazy just because I have to do it through OBS. All right. So can everyone see the, I guess, left hand of my screen correctly? Like now there's going to be a downloads window in it.
Yeah.
Awesome. Okay. So one of the first things I actually want to go over is this. This is Unity Hub. And one of the biggest reasons why this is actually important is because this is literally the start of Unity. And you may be wondering why I'm starting from such a rudimentary level. Why don't I just open the editor or anything? It's because depending on your project, you may very well need a very specific version of Unity. For example, if I go ahead and try to look at, say, Google Cardboard for Unity or Google VR for Unity, oftentimes it's going to ask you, for software requirements such as Unity 2019.3.15 F1, right? And the reason why I'm telling you this right now is because depending on what project or what packages you're going to actually be importing to your project, you may actually need very specific Unity versions. You don't want to install the very latest version of Unity because oftentimes for these packages, especially for things that are specific to devices such as Google Cardboard, or maybe the Oculus, or maybe the HTC Vive, or even just certain Android versions or iOS versions, you'll want to stick to very specific Unity versions. And so I'm starting all the way here because this is kind of an important thing to start to kind of like alleviate all of the problems that you may face in the future. As you can see, I have 4 different Unity versions installed. And only one of this is the latest version. And I don't even have the 2021 version. I just have the LTS version of version 2020. And the amount of times that I've used this version is almost 0. And the reason why is because many packages, especially for things like the Oculus, break on the very newest versions of Unity. And so therefore, if there's some cool feature that I want out of Unity that I want to test out, I'll use the latest version. The fact of the matter is that you want to basically try to find what project you're trying to do. Let's say you have an Oculus Quest 2, for example, a virtual reality headset. You basically almost immediately want to go to the documentations, look for what the software requirements are, and install almost that specific version. And once you download Unity Hub, that can be very simple. You just click add, you go into installs, and you click add, and then you just pick whatever release that you need. If your release isn't here, you'll basically have to click this link, which takes you to the download archive. And in this download archive, you're going to see every Unity version all the way to 3.x. And the very latest version, or basically the oldest version that's usually supported, is Unity 5.x. But most packages now require something newer than 5.x. And you can see there's all of these different versions. So I think there's a really important step because packages are often a lot slower in updating than the Unity install or the Unity version that you're going to be using. Secondly is when you get into Unity Hub, you can see that each and every project that you create or you add has its own specific Unity version, just because you're going to be using or you're potentially having multiple Unity versions depending on the software packages you're using, etc. So as you can see here, I have this project called Test Project 2, and it's using 2018's version of Unity. And the big reason why is because Google VR, Daydream, and Cardboard basically require the 2018 version because the Unity editor doesn't have XR extensions anymore past 2018. So great. If I wanted to do Google Cardboard and I use 2019, all of the C# scripts that are within the Google VR package are going to break. And that's the biggest reason why you need a specific version. But you can see some of these newer ones, like for your Oculus, is on the 2020 version. When you click New, you can click New and it'll default to whatever Unity version you've used last. But if you click this down button over here, then you can essentially create or select a new project. I'm going to create a new project. It's going to be 2018.4.35f1 because the latest project I opened was actually the Test Project 2. And I can name this whatever I want, VR Bootcamp, let's say, and I'll click Create. What I will say is that as we go along, and I've made this entire emphasis on versions of Unity, one of the most frustrating parts, I feel, of Unity is depending on what version you're using, the interface may look somewhat different or slightly different. So the 2018 version actually looks pretty different to the 2020 version. And that's one of the biggest reasons why I didn't want to harp or want to focus on every single little nitty-gritty detail within Unity. And that's because depending on the Unity version that you even use, it might actually be different. And so you may be trying to look at the wrong place or in the wrong place from what I'm teaching you right now. Here is the Unity editor, and hopefully everyone can see mostly the entire Unity editor, I believe so. So we're in this scene view. The scene view is kind of like the easy edit view where you can basically move yourself about the kind of like the environment that you're in. One thing that I want people to understand is that the scene view is not the same as the game view. It's not the same as what the players or the people are going to be seeing when they run your game. That is not in this scene view, as you can see in the top left. That's in the game view, which is also in the top left, but 2 tabs over. This is what the player sees when they run your game. And so I'll go back to scene view, and whenever you want to run your game for testing, for example, and you don't want to just compile your game already, you can click the play button, and it'll give you an instant preview of what the player would see if they ran your game. And so as you can see, I see absolutely nothing. I see a skybox basically, and nothing in it. So, okay, that's kind of boring. There's literally nothing in our scene. I can add 3D objects pretty easily by just right-clicking on this hierarchy view down here. Oops, zoom is in the way. This hierarchy view down here, and you can see something that says sample scene. Now, you don't need to worry about the name of the scene, which the name of the scene is sample scene. What you need to be aware of is that any game object that you add here is specific to sample scene. So for example, if I right-click, I can add a 3D object like a cube. And as you can see, a cube has appeared in our scene. If I click game, then this cube is like pretty far away. It's all the way there. One thing is that, for example, I have this scene, and if I go ahead and save this scene as sample scene and I create a new scene, as you can see, the cube is now gone, right? However, sample scene by default is actually saved within assets, as you can see here in this project folder, assets, scenes, and then here's sample scene. So if I double click it, the cube has reappeared. So whatever game objects you add to a scene is specific to the scene, and you can save the scene and it will preserve all of the game objects within it. Think of it as a level. If you have like a non-open world video game, for example, each scene is basically a level or each individual level, and you can add more and more levels to your game. So that's basically the very, very basics of what you first see. There are a couple of things that you'd want to be aware of, and that's something that I've already talked about before, game objects. And secondly, the components as part of those game objects. So as we can see here in this hierarchy under sample scene, we have actually 3 game objects. The main camera, the directional light, so this is the light source, and a cube. Now, as you can see in the inspector, which is in the rightmost part of this window, if I click on cube, cube has several components. It has the transform component, it has the mesh filter, it has the mesh renderer, it has the box collider, and it has a material component. So there's a ton of components as part of this game object. Components are essentially the add-ons to the game object that give the game objects property. For example, if I go into assets and I create a material, so material is kind of like what color the game object is taking on. What is it? Shiny? Is it matte? Is it whatever? So if I go into material, I'll name this material red. And under main maps, I'm just going to change this color to very red. And as you can see now, this sphere is now very red, and it's basically trying to tell me in real time what the game object is going to look like if I apply this material. Look at cube right now. Cube has a default shader material, but I can't change it at all. It's just the default material. But the moment I drag this onto it, suddenly this component, the material component of the cube, has changed. And it will also take on whatever properties that this material has. So think of components as things you can add on to the game object. Now, it's not as clear-cut as you may think. For example, this may be a cube, but if I take away the mesh renderer, suddenly the entire cube turns invisible and all I can see of it is a wireframe. And that's because the mesh renderer is actually a part or a component of the cube that gives it its 3D form. If I take away the mesh renderer, it's gone. That is different from disabling the entire cube in its entirety. This checkbox right here next to the name of the game object completely disables the entire game object. But what that means is that it disables all of the components of this game object, not just the mesh renderer. Because technically speaking, this cube, despite not having 3D form, still has a transform. It still has a position within this 3D landscape, even though technically, if I go into game, as you can see, you can't see it anymore. And if I go into the mesh renderer and essentially reactivate it, and I go back to game, suddenly I can see the cube again. So there's a difference between disabling components of the game object and disabling the game object in its entirety. The last thing I kind of want to talk about in here is just how do you script anything, right? And so for the basics of scripting, all you essentially have to do is go into create, and you can create a C# script. So Unity takes a bunch of different programming languages, but likely the one you're probably going to use is C#. It does support other programming languages, like a different version of JavaScript, but I won't get into that now. What I'll get into is C#, because many of you are from UTC, and UTC teaches Java, to which C# is somewhat similar. So you can name this script whatever. I'm actually going to name it whatever. And with the C# script, you can actually see a quick preview of what the C# script contains. You can double click the C# script, and Unity, when you install it, automatically also installs Visual Studio 2017. Regardless of what version, regardless if you install Unity version 2021, it's going to install for you Visual Studio 2017. Why? I don't know. Point is that when you create literally any script within Unity, it's automatically going to put this like default code inside of it. And this is actually quite helpful, and it's because there are several things within this that are pretty important to know. First is void start, and second is void update. So for any of you who have taken programming classes before, you know that void is a method that returns nothing. For those of you who are less familiar with programming, it doesn't matter. The point is that void start essentially runs all of the code that contains within here when you click the play button. So you remember the play button right here? If you click the play button, this code immediately runs. So whatever you put in here, well, it already says it right here. Start is called before the first frame update, which is essentially when you actually click run. And also what you see here in update, as you can see, it says right here, update is called once per frame. So every single frame that your game runs, every single update your game runs, it will run this void update. So let's put an example of what scripts can do, for example. One of the biggest things that I'd like people to note is that scripts have the capabilities of changing components within game objects. So remember, I said that this cube has many different components. It, for example, has the transform component, which you can change through scripting. So if I go into here and I essentially say, for example, GameObject.transform, so it's going to take the transform component of a game object dot rotate. I can give it a vector 3 of Euler angles. So because it's going to be run every single frame, let's say, for example, I'm going to rotate it like sideways. 10 times time delta. Oh, sorry, delta time. And then 0. So for people who don't quite know what's going on here, essentially on the x-axis, I'm going to rotate no angle whatsoever. On the y, I'm going to rotate 10 times how much seconds has elapsed since the program has run. And then 0 on, I'm going to rotate 0 degrees on the z-axis. Whenever you're scripting, make sure to do file, save all, or file save. And there are shortcuts. Obviously, you can just do Control-S, and that's the easiest way to do that. Because this is not Unity, there is no relation between Unity and the script that you're writing, and therefore there's no autosave. And so Unity can, in its debugger, actually tell you the errors that have happened when you were, or that have happened within the script that you've written, but there's no telling whether or not you actually saved your script. And so if you're clicking the play button and nothing changed, then that's likely because you haven't saved your script in the first place. So many of you are like, okay, you wrote that code, great, it's not running. What did you do wrong? Well, this code is not even attached to anything, right? If I want to attach a piece of code to a game object, all I need to do is drag it onto the game object. I can do it from this project into the scene view, or I can just drag it into the cube in this hierarchy. So now when, as you can see, main camera, directional light, and then you have your cube, I drag this script, whatever, into cube, and now it gained another component, and it's the script itself. Before I hit play, I need to tell you a little bit of what I actually did. Game object is essentially whatever game object the script is attached to. The confusing part is that lowercase game object is different from uppercase game object. Uppercase game object is the class. Lowercase game object is an actual object. And lowercase game object becomes the object that the script is attached to. Uppercase game object is the class. So make sure you don't do capital game object if you're planning to actually attach a script to a game object. I'll let you know how to actually use capital game object later on. But for now, it's simple to say that game object is actually attached to a game object like the cube. So it will take whatever component is attached to this game object that it's a part of. Transform essentially just goes through the transform, and then rotate just changes the rotation, this rotation values on the cube itself. I can go ahead and click save. I'm kind of like, paranoid about not clicking save just because there are many times where I've tried to run something without saving. And now, as you can see, now that I've run it, look, the cube is rotating. Now, there are a lot of times, right, where you don't want this to happen. You don't want to make a script for every single game object that you have in your scene. Now, you could potentially have one script and drag it to every single object, but that's not useful, and it's kind of tedious. I'll get into essentially the very basics of manipulating different game objects without having to drag a script into it. So I have this red cube, and I'm actually going to name it red cube now. And then what I'm going to do is I'm going to create another object, and it's going to be a whatever cube. It's going to be whatever here. And what I want to do is, for example, let's say I have a bunch of, cubes. I don't know why I would have a bunch of cubes. A useful thing that you can do in Unity is you can tag your game objects. Tagging your game objects is like making game objects in a subclass, like a subcategory, that you can manipulate by finding the tag itself. And that seems a little intuitive in terms of the explanation I just gave. But essentially, what I can do with this white cube is I can go into tag. I can say that I want to add a tag. And I'm going to create a new tag. It's going to be, I don't know, rotate cube. I'll click save. And here now I have a rotate cube tab. Or tag. I can click the cube and I can assign it the tag I just created. So rotate cube. So, okay, I'm going to go save the scene really quickly. And now I have two cubes, this red cube and this normal cube, but the normal cube has the rotate cube tag. Remember what I said about capital game object? I can write code to actually manipulate other game objects, and one of the easiest ways to do that is by doing it through tags. It's not the most efficient way, but it is the easiest way. So I'm going to make a new line. I'm actually going to comment out this line. So commenting out lines is double forward slash on any line. And I'm going to write the same piece of code, but I'm going to actually manipulate another game object through a tag. Capital game object, because I don't want it to be the game object the script is attached to. I want just the class game object. Dot find object with tag. And in this find game object with tag, I can actually feed it a string, and it's the string of whatever tag that I want to manipulate. So for example, rotate cube. Now this entire object becomes whatever object in the Unity editor that has the tag rotate cube. Then I can write the same thing again, and I commented the thing so I don't have to retype literally everything. And as you can see now, the code has changed from, okay, just rotate the cube the script is attached to rotate to the cube that actually has, or rotate the game object that has the tag rotate cube. I can click save. I can run this. And suddenly, even if the script was attached to this red cube, as you can see, the red cube has the actual whatever script component. And the white cube doesn't have a script component at all. As you can see, there's no C# script here. It is the white cube that's actually rotating, and it's because that's the one with the tag. So that's the very, very basics of the Unity editor and scripting. I will like to say that, you know, for most things, scripting has to do with changing game object components. There are a bunch of other things you can change, and it has to do with things like shaders and actually projects. Sometimes it even has to do with the editor itself. Sometimes you can extend the editor of Unity. I would get into that because, like I said, those kinds of things are very project specific, and it really depends on how much you want out of Unity and what you're planning to do. But that's the very, very basics of getting game objects and scripting and essentially making sense of, you know, how to manipulate game objects. There are a couple things within the Unity editor that I'd actually like for everyone to be very aware of. And the reason why is because you're going to encounter these things so much when you follow documentation. Like I said, you need to pretty much follow documentation pretty stringently for many of the packages that you may be importing into Unity. So let's get started. The couple of things that I'd like you to be aware of is the actual menu system and the settings that you'd like to manipulate. When you click onto File, there are many options here. Pretty much the most confusing and potentially unnerving difference in Unity compared to maybe other programs is that there is 2 saves within Unity. There's the Save button and the Save Project button. The Save button doesn't save the project. It saves the scene. Remember the sample scene? You know how I can delete something and, you know, oh, sorry. And now the scene has changed because now there's an object missing. When I click Save, it actually saves this scene, but not the project itself. If you want to save the project, then here's Save Project right here. So what does Save Project have to do? Like, what does Save Project even do? Considering that if we save the scene, we also save off the components within the game objects, yada, yada, whatever. What Save Project actually does is many of the other settings and potentially many of the other things that are not specific to the scene, including things like lighting and shaders. So one of those things is actually just your build settings. As you can see here, we have the build settings, and there are many different platforms we can actually build for. Now, what platforms you have available to you is very dependent on what platforms you've selected in the first place. If I go back to the Unity Hub, and I go into installs and I add an install, if let's say, for example, I want to install Unity 2021. You can see here that there is a lot of platforms that you can essentially pick and choose for yourself so you can build to that platform. As you can see, some of these platforms are actually unchecked, and therefore I wouldn't be able to build into these platforms in these build settings because they're not checked. So I don't have the capabilities within, if I installed this version of Unity, I wouldn't have the capabilities of building to Mac or building to Linux because I haven't checked them. But it's as easy as just checking these boxes. What I will say is that if you're trying to build to iOS or iPhones, you would really, really want to be developing on a Mac or on Mac OS. And that's going to make your life a lot easier, mainly because you have access to Xcode and many of the developer tools that are specific to Mac OS, which are specific to iPhones and iPads. But that's besides the point. As you can see here, we have many different platforms. And platforms can be very important, especially if you're programming for some standalone devices, such as the Oculus Quest 2. The Oculus Quest 2 is a VR device that actually has its own processor, and it runs Android. And therefore, if you're building for the Oculus Quest 2 and you're not using it to hook it up to a desktop computer, you're actually going to click Android, and you're going to click Switch Platform. You're actually going to switch the platform of the entire project into Android. The reason why I'm getting into this is because you would actually want a different, as tedious and as annoying as it is, if you're not familiar with Unity and you're not comfortable yet with essentially making everything that you code cross-platform, you would essentially want to create a project for every single platform that you're actually developing to, most especially if you're planning to program for iOS. And the reason why is because Vuforia, for example, which is an augmented reality / virtual reality thing, will run into issues when you try to switch platforms, even though it's the same package. And you may need to write things very differently depending on the platform you're building to. So this is one of the settings that I'd really like you to be aware of, because they're going to ask you to open the build settings and then you don't know where it is. It's under File. Player settings can be found in two areas, but the easiest way is just to go to File, Build Settings, and Player Settings is down here. This is another very important thing because especially for VR, they're going to be asking you to go into player settings, and player settings, when you click it, opens up in the right-hand side, not a new window. Player settings, they're going to tell you to go to XR settings, and they're going to want you to click virtual reality supported. So you're going to click that, and it's going to do its thing. And then after you click virtual reality supported, they may want to ask you to add, for example, another VR headset. For example, if there was a specific VR headset, they'll make you add that. I'm going to uncheck that for now. And essentially, I just want you to be aware of these player settings because they can be very important in like setting some of the settings of your project. For example, your app icon, your logos, the other settings such as the bundle identifier, which may be very important when you're actually building and deploying it to, for example, the phone, or you're trying to publish it to the App Store, yada, yada. And especially for Android devices, we'll get into it later, you want to set a minimum API level, but that's besides the point. So we've went over two panels that you should be aware of. The last panel that I want you to be aware of is the preferences panel. And the reason why this can be important is because external tools is pretty important. So the preferences panel is found within preferences, or edit and then preferences. On macOS, it's a little different, but I unfortunately don't remember it off the top of my head. The point is that you're going to go into external tools, and sometimes they're going to ask you to configure your settings here. For example, a manual provisioning profile for iOS or an Android SDK. Now, this is where it really gets into the weeds. And this is why programming for Unity can be a little hassle. And that's because different phones and different Android devices, or different mobile devices, I should say, require different things. For example, here's Android Studio. You essentially need this if you're trying to program to Android, because if you don't have this, then you won't have an SDK, and then you won't have anything to actually build it into your phone or whatever thing you're trying to deploy to. So if I'm deploying to Android, I literally had to go Android Studio. I have to click configure and then go into the SDK manager. And then I have, so I daily drive an iPhone, but deploying to Android is just so much easier. It's like 5 billion times easier than deploying to iOS, unless you have a Mac, to which it's a similar experience. And my Android device here is Android 9. So suddenly I need to know the version of what version my Android device runs. And then under SDK tools, I need to make sure that I have SDK platform. So these are very specific things that are specific to Android that you already need to know. And then you need to know your Android SDK location and be able to put that in here so that Unity knows how to deploy it to the device. Okay, so those are the setting windows that I want you to be aware of. Build settings, player settings, and preferences. And that's because these are, when you're following through documentation, these are the most important. The last thing I want to go over is actually the asset store and finally deploying to a device. So the asset store is different depending on the Unity version. Yes, this is very annoying, but guess what? What can we do? The asset store is a great place to actually not only find plugins. For example, if you need a plugin for, I don't know, the Oculus Rift DK2, which is a really cool old VR device. And you can also find things such as assets for scenes, such as, I don't know, Dreamscapes maybe. Sure, let's go with Uncharted Lands, whatever. The asset store is essentially a very easy way, if you don't have, you know, your own models, your own assets that you want to add. It's a pretty easy way to actually gain assets and essentially have a scene that's already pre-built that you can modify with all of the objects that are within it. As you can see, they're paid. Some are, well, a lot of them are free. But the point is that the asset store is a great place to start, especially if you're just prototyping and you're trying to make sure, or you're trying to have a realistic environment of, you know, whatever thing you're trying to program. Or for example, your project doesn't focus on visual design, it's just focusing on whatever gameplay or thing you want it to do. And so as you can see, all of these things already have their own shaders, their own, you know, assets, and their own camera settings, etc. One thing I want you to be aware of, though, is much like everything in Unity, supported Unity versions is something that you want to be aware of. And you also want to potentially look at the reviews and say whether or not, you know, this is worth using, and also the Unity versions that may or may not work. The reason why I'm talking about the asset store is because you have things like this, but you also have things such as packages that you can import. And one of the packages that I'm going to import, and in order to import a package, you go into assets and then import package. One of the packages that I'm going to import is actually within my downloads, and it's Google VR for Unity. I'm going to click open. It's going to say preparing the package. And as you can see, there's a whole bunch of scripts, shaders, blah, 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 whatever, for Google VR for Unity. I'm going to go ahead, and after I imported the package, I'm going to click import. So where did I find this package? I essentially went into Google VR for Unity, there's a documentation page. It recommends you a Unity version, and then you essentially download the Unity package, and it installs all of the scripts that you need to actually interface with the Android device. So Google VR is for Android devices. Okay, so I imported it. Now what? Like, what happened? Probably one of the easiest ways to actually get into a package or to use a package is to try and find a demo scene, or a scene, as I've talked about. A scene is whatever has all of these objects and components and potentially scripts in it. So in Google VR, or in most packages that you're going to import, other than some very specialized packages, they're going to have a scenes folder somewhere in here. As you can see, there is no scenes folder, but it's pretty easy to, like, you know, be able to infer that maybe there's a scenes demo or a scenes folder within demos. And sure enough, there is scenes. So under Google VR demo scenes, we have several scenes that were created by the developers in order to just have a scene to get started. One of them is Hello VR. And as you can see, very simplistic scene. You're basically just transported into this room. And as I've told you before, this is not what the player sees. This is what the player sees in game. And that's controlled by the actual camera, as you can see here. So, okay, I have this scene now. I click play, and it says, please select a Google VR platform, blah, blah, blah. One of the biggest things, like I said, is you need to be able to know when to switch platform depending on what project that you're doing. So because it's Google VR, guess what? I have to go into File, Build Settings, Android, and now I have to click Switch Platform. And what it's going to do is it's going to recompile all of the scripts and everything. And then we're just going to have to wait while it converts this entire thing into DirectX 9 so that it's actually renderable on Android devices. And so we're going to have to wait. And now we're here. I'm going to run this again, and then it's going to complain again. I already know it. And it says, player settings, virtual reality supported is checked. So, okay, the next thing I have to do is know where player settings is. Like I said, that's under build settings, player settings. And remember when I said XR settings, they want you to click virtual reality supported, boom. Click that. It says here the virtual reality SDK's list is empty. I'm going to click this add button. And then I'm going to add both Cardboard and Daydream. So now we have both of that. I can close out of build settings. I'll run it again. And now it works. This is just a simulation of what the player sees. And Google has made it pretty easy, because they wrote a script for it, to demo what you're potentially looking at. You just have to click Alt and then, or press down Alt, and then you can simulate looking around with your mouse. Well, that's not helpful because it's not actually VR. So the next thing you want to do is basically deploy it to an Android device. Now, Instant Preview used to be a thing that worked pretty well until Android SDK decided to update its platform tools. So I can't really get into that. What I essentially have to do is I have to go under, and again, this is like the nitty-gritty of Unity and different packages, and it really depends on what you're trying to do. But here I am under Android. I'm going to click my LG V30, which is the device I have plugged into my computer with Android debugging and everything. I'm not going to get into it. And then I also know I basically have to go into other settings, and then I have to change the minimum API level to at least Android KitKat or Android 4.4, even though my device runs Android 9. And then what I can do, and It used to be as simple as just clicking this play button, and what will happen is that on your phone, it will basically stream an app to your phone. The phone will run that APK, and then you can, manipulate the editor in real time using your phone that's plugged into your computer. But it hasn't worked in quite a while, or I haven't gotten it to work in quite a while. So what I essentially have to do is go click build and run. I give it a name. The name doesn't matter. It can be p.apk. I picked P because it was the closest thing my fingers were on. And essentially what's going to do now is it's going to try and build the actual, oh, this is not going to work. I forgot one last thing. Well, this is a learning point for everyone, and this is something I constantly forget. And we'll get into it pretty soon, but we're going to have to wait for this to build. I'm going to show you that there's literally nothing that's going to show up on the phone, and it's a little unfortunate. One thing I'd like to say is that, this is actually easier if you are using a standalone desktop, or not a standalone, a desktop VR headset, because you don't have to go through the nitty-gritty of like Android and blah, 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 especially if it doesn't have its own processor. So if you don't have like an Oculus Quest 2 or something, this is actually a lot simpler because you can deploy for desktop. But I don't know where our Vive is, so I couldn't do that today. So my phone essentially has VR on it. Funnily enough, it actually rendered correctly, but as you can see here, it's rendering in Google Daydream or Google Cardboard. And as you can see through my webcam, sorry, you have to look at it through my webcam, but we have a VR experience over here. And everything that I've told you about for like deploying it or whatever, or not deploying it, for scripting and stuff like that can be fully done in this scene. You can just strip off the walls and suddenly add your own stuff, and you're off to the races because everything is already set up for you. And this is true for many VR devices, but like I said, specific to whatever you're trying to do. I'm actually surprised that the scene that it has taken on actually rendered onto the phone. And one of the things that I want to talk about is when you go into build settings, there is this peculiar and kind of annoying thing, which is scenes in build. If you run a project, let's say you build and ran a project, and you don't see anything. None of your changes are on the device or are on the built project. That's actually because you didn't add any scene. And so Unity is just going to render nothing at all because there is no scene. And therefore there is no game object, there is no light, there is no nothing. So if you have that problem, you have to click add open scenes, or you can drag scenes into this box, all of the scenes that you'd like to include. And it's a little annoying that that's the case. A lot of times I wonder why don't they just include all of the scenes when you're clicking build and run, but it's likely an optimization feature so that you save on disk space, potentially for scenes that you don't even want to add in the first place. So that's essentially it in terms of going from installing Unity to building a very simple script that manipulates components to essentially deploying a VR scene onto a device for VR. The thing I just showed you on the webcam, you'll need one of those Google Cardboard things, or like, VR goggles for mobile phones, which are pretty cheap. And you can just deploy to your own phone and it'll be as simple as that. I really stopped myself from going into very specifics because, like I said, it's really just different. In fact, if you're deploying to iOS, almost everything in the past 20 minutes or not 20 minutes, maybe like 10 minutes of like Android SDK and all of that sort of stuff. And even importing Google VR is going to be completely different. So I'm not going to get into the weeds, just depending on, you know, what you're trying to do with the project. But that's essentially it. There are some things that I think is very important for you to know, such as switching scenes, etc. But for the most part, those things are pretty intuitive. And not only that, but there may be better ways of actually switching scenes depending on, again, what packages you import, etc. So that's essentially it. That's all of the things that you need to really, really be aware of, from creating a project, knowing what a scene is, knowing what game objects are, knowing what components are, knowing how to attach scripts and how to manipulate the components of a game object, importing packages, as well as knowing the assets stored to which you'll have different scenes and different assets, like even just this room, to essentially building and running an app and deploying it onto a phone, or it's not that different. If you want to deploy it, you'll just, or for PC, you just switch platform and then you build it and run it, and then you'll get an exe file for Windows or a .app file for macOS. I don't know what you get for Linux, actually. I think you potentially get a script file that you run in terminal, I think. I'm not actually sure. But anyway, not that different in terms of that. So everything that I've talked about other than Android SDK is pretty much relevant for everything that you're going to do, at least for Unity and VR. So, sure, we can reload that. In terms of C# itself, this is something that I wanted to get into, but I won't get too much into. C#, if you know Java, is a lot like C#. It's very intuitive to get into. What I will let you know is that the C# included in Unity is old and doesn't have a lot of .NET specific libraries, or .NET specific, whatever you call these, packages, code packages. I don't know what they call it in Java, but libraries in Python, if you know Python. And the reason why I'm telling you that is because for things like even just reading JSON files, you're going to have to basically download a JSON folder, or like let's say, for example, lit.json. You're going to have to download lit.json as a folder, put that folder into, I don't know, your assets and scripts, then import the C# script from that lit.json folder into here, because you can't use Microsoft libraries, because the Microsoft library that you need is too new and doesn't actually include JSON reading if you're trying to access it through Unity. So there is a lot of jank within the C# version that's found within Unity. So I want you to be aware of that. For the people who are very familiar with coding in the first place, you really, really want to be sure that you're trying your best not to rely on system packages, or system packages are included with the Unity editor. There are also a lot of Unity specific packages, but again, like what I've said before, the packages that are included changes within every version. For example, here, Unity Engine.xr exists within 2018, but it doesn't exist within 2020 version of Unity. So now you're going to have to do a lot of code porting, and that's just an entire hassle that I feel, depending on what Unity version your project requires or your package requires, is the best way to deal with that problem, is to essentially look into documentation and see what Unity version they want you to use. So yeah, that's essentially it for all of the basics. Are there any questions?
Dex, I have a question.
Mm-hmm.
But the asset part, how about the script? Can you just example? But I don't know. Just is there any kind of script for the what's it look like?
I just opened the script, but the script is not useful. Let's see if we have some script, for example, here. Okay, this seems like a decent script to look at because it doesn't have a lot of decorators. Oh, did I open two? No. So
attach it to a specific thing, or just to all the assets, just the.
Well, so this script, I'm actually not sure if it's it looks like a class script because it doesn't actually have, oh no, it's an actual script attached to a game object. And the reason why I know this is because there is an on-enable, on-disable, a start function, and a loop. That's an IEnumerator. But the rest of these functions are just auxiliary functions that essentially do a bunch of processing in terms of, okay, where is the headset, and by the headset it means the phone, compared to the height or the floor height. So these seems like a bunch of debug slash processing functions, and then here's the actual functions that do a lot of the, I don't know, the processing of the headset itself. And as you can see in this status update loop, it just runs everything. To what script this is actually, or what game object this is actually, what script is this? Headset demo manager, I'm not sure. You're basically just going to have to, okay, so it's attached to demo scene manager. It says headset demo manager. And if we look at all of this, then we can see that it looks at GVR headset, which is a class. But I don't know what actually changes the values within GVR headset, which would mean that there should be some other script. Let's look at these other scripts. There should be some other script that changes values within GVR headset in order to do things like this. But it's not that either. It's probably somewhere in here. I just don't know which one it is. I'm gonna try and look for a decorator now. Is it this? No, this is a bunch of settings. Yeah. Well, I don't know if I answered your question though, but there's a here are some sample scripts.
So you can code in each object, right? Each is like this, each cube or.
Yeah, and actually, more importantly, you can manipulate. I guess I went through so much of the basics that there are a lot of things that you potentially would like to know, but you can manipulate game objects. You can also manipulate sub-game objects. So game objects under game objects. That being said, it may not be relevant for too many of you, but I'll go open a Unity Hub project. I'll show you two projects. One is a point cloud, and the other one is I'll do final demo product, sure. So the reason why I can open several different Unity projects is because for the most part, these are all different Unity project versions. We have 2018.4, 2018.1, and SalScan is 2019 point something. I don't know where it is though. Oh, it's still opening. So one of the things is that, for example, we have this female, ooh, I'm in game C mode. We have this female in this field. And what you can do is you can actually manipulate sub-objects. So if I go into female, M3D female, and I do, for example, pelvis. As you can see in this hierarchy, this is a game object, but it's actually a game object as part of another game object. And zoom is in the way. I can change the transform of this. Now, obviously, you don't want to do this. This may seem intuitive, like if you want to move your hand, like you want to be able to move it forward. Like if I want to move my body forward, I would essentially want to move it forward like this, but that doesn't make any sense. And if you really think about it, your body is a bunch of, you know, angles. Your body doesn't stretch out necessarily. It's just that, for example, let's say my elbow, right? It's really just changing its angle. And so how you actually want to manipulate, for example, body models is you want to change the rotation of it like that. Because really, when you scrunch your stomach, you're just changing the angle of your stomach. Or if I go all the way down to thigh twist, I can move my thigh this way, but it doesn't really make sense for me to move my thigh this way, right? And then I can do something like this as well. Now, it doesn't make sense for the need to rotate this way, but it does make sense for the need to rotate this way. So that's one example of sub-game objects. The other thing, if we get into more of the specifics, is I'm not going to save that scene. Here's a point cloud scan. This is, oh gosh, I lost myself completely. Uh-oh. Where is it? Oh, here it is. So, oh gosh. Well, here we go. It's going to be very difficult to, okay. So here is a point cloud scan that I created through a custom mesh. And this scan was actually done through a script because nobody is going to try and make a custom mesh with like 13 million points and then put it as game objects. This is a very specific use case of Unity, and it's not that easy to do, but essentially these are not game objects. This is one game object, but each specific vertices or point within this object is a particular point within the point cloud. So this is one game object, but what I did is I actually manipulated the mesh so that the mesh is the one that takes on every single individual point. This is, again, very specific to what I was trying to do, but the point is that these points, if you tried to do it, if you tried to make 13 million, let's say, points on Unity through game objects like 3D cubes, it's completely infeasible. And that's because Unity now has to track 13 million objects with and however many components each object has. And so it's potentially on the order of like several 100 million components just for rendering a point cloud. And it's very inefficient because many of the optimizations, for example, rendering occlusion, doesn't work with that many game objects. And so you want to actually manipulate the meshes and stuff. itself because the vertices have rendering occlusion, which is an optimization to which if the camera can't see behind a vertex, then all of the vertices behind it won't get rendered at all. And many other things that I really don't want to get into. If you want to see what this looks like, I'll go back into scene view. As you can see, this point cloud is rotating. However, I do know probably because the amazingness that is zoom, this is probably going to look really laggy, even though it's very smooth on my end. But what can you do with that? Anyway, so yeah, there are a couple of ways you can manipulate stuff. Also, scripts don't only manipulate components. They can also manipulate many other things, such as like even just shaders. But again, it may very well be you don't ever have to do that, depending on your project. So. Any other questions?
Yeah, please just turn on your, the microphone, please. Yeah, any questions? Just take this. People still thinking about it? Don't be shy. So. Dex, if we just want to go to the competition, I think we should base on the work that you have done, right? The first one that you show us, the nurse,
Mm-hmm.
Yeah, go ahead. Sorry.
No, I was wondering what the question was. Sorry.
So I think which direction should we go to? Just we should keep just the extend that work, or just do something what kind of new function should we add for the VR for the?
We should extend what we have. So this is a question very specific to my project, I guess. Mm-hmm. But one of the biggest things, or one of the biggest reasons why we should just extend that work is because everything is already pretty much set in place in terms of what works and what doesn't. It would be a very big, I guess, hassle, if you want to call it that. Mm-hmm. If we try to make a new project, we'll have to essentially go through all of the configuration all over again. The configuration I did for Google VR was very simplistic in comparison to essentially, for example, if you have to use a Unity version and suddenly you have to port a piece of code or a package, an entire package, and port that entire thing to be compatible with that newer version, right? Mm-hmm. And so extending the work is going to be a lot simpler just because we don't have to do all of that again. Now, when we get the Quest 2, and one of the reasons why I created a project from scratch is because essentially I can port over many of the scenes that are already within the old project and just reconfigure and port it to be compatible with the Quest 2. But doing it all from scratch is going to be a really big hassle, especially considering I already set up the Azure Connect and everything. So.
Okay. So you said that we have the object, we have another sub-object, we have a sub-sub. We can, right? Technically.
You can go down, I want to say unlimited, but there's Unity probably limits you somehow. Mm-hmm.
So that one was that one was your body, right? It's you pay that, right? That is human. That hierarchy object. It's
No, I didn't pay for that. You paid for that.
Okay, I thought who pay it. Okay.
Oh yeah, Dr. Wu paid for that
I
many
see.
years ago. Yeah.
Mm.
Now, for the students who are wondering, yes, you can create your own objects through Blender or whatever, uh, you know, editor you use. However, there are specific requirements that you need to do in order for them to be renderable in Unity and also for it to make sense in Unity. So you may, especially if you're trying to make your own mesh, it may get very, very frustrating and very, very peculiar in importing meshes from one, for example, from Blender into Unity can get very frustrating because there may be quirks such as one side of the wall not rendering, for example. I know that has happened to Ale and Suhail many years ago. They create their own models through Blender and suddenly one wall of an entire building just didn't render and nobody knows why. So you may run into those problems. And so unless you're getting assets for Unity or you're very, you know, familiar with how to build 3D assets for Unity, you may run into some struggles.
Okay. So right now the two functions I say we have to be overridden. One is the start, another one is update. I said there's some other one, right?
There are several more. Like I said before, on disable and on enable. Mm-hmm. And then there are things such as on update. And I guess what I'm trying to say about that is start and update are the two that are basically included within default scripting, or when you create a script, it's like the default code that's put into it. And literally probably like 90% of the times, those are the functions you're going to use. On disable and on enable are very useful, but again, really depends on what you're trying to do. I feel like I'm really becoming a broken record saying that. So there are a lot more functions. You can look through the documentation to see if that functionality exists within Unity Engine, and then you can just use that.
Okay. So for the June 10th, the face-to-face, like the hands-on, we can see that hands-on. So what do you want us to install the Unity3D? Everybody to install it on our computer?
No. And the reason why is because depending on your computer that you're using, it may take very quick to absurdly slow, depending on what computer you have. For those who are wondering what the computer specs I'm using for the computer I'm hosting this Zoom on right now, I have a Core i9 7900X, 64 gigs of RAM, and a 1080 Ti. And sometimes I feel this computer is slow. So I know, for example, programming on my laptop, which, where is my laptop? It's probably in my bag, which has a Core i7 8550U and an MX150 and 16 gigs of RAM. The Unity editor can be a little cumbersome, especially in larger projects. So you kind of need a, hate to say this, but you kind of need a gaming computer, especially the larger the project is. And then for VR, you really need a good computer for VR. Now, if you're doing VR on like an Android phone, you can get away with any computer or laptop that you have. If you're doing like something like Google Cardboard, like what I showed. And that's because your bottleneck is not so much how much your computer can render. Your bottleneck is how powerful your phone even is. And depending on the phone you have, you may have to do a lot of optimizations anyway, which will make it run fast on your desktop or laptop. What I will say is that unless you have a very specific VR headset, such as like, I believe Qualcomm has their own processor for VR processing, and it's essentially the thing that's found in the Quest 2. What I will say is that iOS and iPhones and iPads are significantly faster than practically all Android phones out there, just because of the Metal API and because Apple, in terms of silicon, is much further ahead than Qualcomm and Samsung and Huawei and all of the others, which is a little absurd, but unfortunately that seems to be a reality, is that Unity just plays and runs so much better on Apple devices.
Okay. Question, I thought who is here? I thought who is the...
Yes, I'm here. I was late for.
Oh, it's fine. I thought just you were at airport or just testing something.
Yes, I just went to the lab to get the result.
It's good? Positive? Oh, no. It's negative?
Yes, negative, definitely.
You take the picture, right?
Yeah.
Okay, that'll be great. So, I think the DACE give a very good, just a good overview about how to use the Unity, the 3D to develop a project. So I hope that everybody can take a look at it, spend some time. And I saw there's some online like Unity 3D editor. DACE, have you tried it? It's online.
An online 3D editor? No.
Yes. I googled that yesterday. But I'm not sure. I have not tried it. I'm not sure whether or not it works. So.
No, I'm not aware. I wonder. Huh.
Yes, and
I wonder how that's even coded.
I don't know. I didn't try.
Well, 3D rendering. I mean, I'm sure you're aware of before, like, especially in the earlier days of the internet, there were things such as, well, Unity was one of them, but also like Flash Player and all of these other like add-ons, or like Shockwave Player. These like really old add-ons to extend the functionality of web browsers and the internet in terms of what they can render. I wonder how they're rendering 3D stuff now. If HTML5 has like, I don't know how that works.
Yeah, I think it takes some time to get it, but we still need a leader to lead us for the competition. I think DACE, at least in the summer, DACE can give you like the full support. So please, I think that I need some volunteer to lead this just the competition. Yeah.
Let me see. I'm still in the middle of like scripting the bigger Oculus, but oh, did I put clothes on this model? Hopefully I did.
I'm not sure.
Maybe, oh my God. So I think I did. The default model of M3D female literally comes with no clothes. It's jarring. Yeah, there is clothes. Okay, so boom is how the scene looks right now. I'm still kind of waiting for, as you can see, the shading is even really off right now. It's too bright. But if I click play, then things will happen. The point is this is what it looks like without any human movement, because it's not hooked up to the Azure Connect. And I'm still waiting for Oculus VR.
Okay.
So.
Yeah, I think the Dot will get one for you.
Yeah, we will get it very soon.
For people who aren't aware, this is Unity 2020. As you can see, already looks different. The theme is already different. So, yeah.
So you can change the thing, right?
9 older versions, not that I know of.
Okay. So this one is better, right?
No, I don't want people to think that certain Unity versions are better. You really should use the Unity version that's most apt to the packages that you need to install.
Mm-hmm.
That is the most important thing.
Okay. Okay. I think yeah, if no more question, like any questions? Any questions? Okay. Since no more question, next for this topic is the June 10th, right?
I believe so.
Yeah, June 10th. Yeah, we will have more like the hands-on practice. So, okay. Yeah.
And it will likely be on this project with the Azure Connect and everything.
Mm-hmm.
When are we getting the Oculus VR? Because if not, then I guess I'll program for Android for now.
I think it's very soon. I think it's 1 day, right?
1 day?
Yes, it's if you get it from the Amazon, it's only 1 day.
But are we ordering it from Amazon?
Don't is right. It's 1 day, right? Deliver.
Yeah. What do you mean 1 day?
So you just like, for example, if we ordered it today and tomorrow we can get it.
Yes, it depends on the shipping.
Mm-hmm.
Oh, but are we ordering it soon?
Yes.
As long as the dean, reply the email, we just, I think we can just order it. Or I'll ask who can help to order. If he ask me to order, will be quick. If he said, okay, Carl, our colleague, the guy who is responsible for ordering computers, if he help to order, I don't know his speed,
I will knock his door. So may annoying him. Try to keep on annoying him. And one more thing, Dex, don't forget to filling out the form, okay? So that you can get a pay very quickly.
Oh, did they reply already?
Yes. No,
Okay.
what do you mean?
Like, yeah.
Your
I was
payment.
I was wondering if Eva replied already.
Okay, yeah, I forward the email. Don't do that. Okay, no, don't forget to do that. Okay, so.
Yeah, let me check my emails really quick.
Okay, I send you email. I forward to you already. So, okay, thank you.
Oh yeah, I see it actually.
Yeah, thank you for showing up. Okay, so and I will try to catch up with you. Okay, try to if no volunteer, then I will force one person. Okay, to lead this competition. Okay, but it's better. It's better. I think somebody volunteer. Okay, Dao, do you have anything?
No.
Okay, and have a safe trip, Dao. Okay, and
Thank you.
everybody else have a great day. Okay, I will see you guys. We will meet tomorrow, right? In a group meeting.
At 3? Are we still having group meetings?
3 p.m. Yeah.
Okay.
Okay, bye. Thank you. Thanks,
Bye-bye.
Max. Very good talk. Yeah.
Mm-hmm.